Hey, attends! Just gonna log on and do the register. Hey, Shanley, nice to see you. Sorry that I created the stream so late. It's nice that you guys are there waiting. Great job. Thanks, guys. You guys are such stars. Hi, Sams. Let's do the register. Look at that. You guys are on it. You guys are the best. You make this so easy for me. Thank you so much, guys. I really, really appreciate it. Shan's here, Ben's here, Isabella here, Harris is here. Look at this. So easy. Shan's here. Ben's here. Wen's here. Anna's here. Moses is here. Isabella's here. Oh, man, we're doing well. What a great start. You guys make this so easy. Moses is here. Who else? Con, Tong, Vic, Wen, amazing. Con, Wen. Is Andy here? I haven't seen Andy. Whoa, hey, Andy. Ruby's here. Vic's here. Andy's here. Tong's here. Look at this. You guys are on this. Has anyone seen Yura? Yura's here. Oh, hi, Yura. Toby. Has anyone seen Toby yet? Kieran, of course. Is Kieran... Why is Kieran not able to sign in? Why? I've got Rue. Have I got Nick and Ashley? Have I got Ashley? Haven't seen Ashley yet. Oh, you guys are getting really quick at this. It's amazing. Toby is on the way. Wi-Fi problem. Amazing. I have no clue. Come on, Ashley. Where are you? Because he's lazy to make an account. That's amazing. Hey, Nick. Great to see you. Ashley. That's amazing. Toby's awake. Toby's awake. He's here. I have arisen like a phoenix from the flames. It's amazing. Just Ashley to go, guys, and we're all good to go. Look at that. That is the fastest register. Come on, Ashley. Come on. Come on. Come on. Do you guys want to see my t-shirt of the day? 2 moles per liter. Isn't that amazing? 2 moles per liter. Obviously, it's biology. I mean, we use DMQ. We use proper units, not the squishy biology units. Oh, love it. Hey, Ashley, lovely to see you. Thanks for coming. Look at that. Register done and dusted. Wow. Congrats on 200 subscribers. Oh, thank you. Oh, thank you. Oh, I love it. Love it, love it, love it. No, it's 199. Don't ruin it for me, Shan. Oh. You should probably do Q&A for celebrations. I don't know what Q&A is. Q&A? Isn't that questions and answers? Right, guys. Today's lesson we are doing percentage yield. And before, obviously I'm gonna crack on with this. Let's get on. Yes, I have no idea. Or give 200 commendations when we're back. Definitely. Isabel, on it. Yeah, since you suggested it, obviously you get 199 of those commendations. Obviously. So that's like a winner. You guys, you're immediately up for your prize. You'd absolutely hate that. Oh, do you know what? How good would that be? Mr. Duncan gave me 199 commendations in one go. That'd be amazing. Oh, I wouldn't be able to fit all the stamps on one page. Oh, that'd be amazing. Yes, you are my faves. Right, okay. So we are running through the water crystallization homework, which I'm really sorry. Question number 1 was A-level. Oops. I am busy making another one. Look, I've been writing questions. Yeah, I'm doing it. I'm on it. I'm making you one. Yeah. Okay, I'll take it. That's amazing. Love it, Isabel. Right, okay, so I'm going to share my screen with you guys because last time I gave a webinar, I totally forgot to share my screen and I was just looking at a ceiling fan for 5 minutes. Oops. Oh, it makes me giggle. Okay, right, we're on it. Oh, just pulling the keyboard off, which I'm pretty sure I've nearly broken already. Oh no. Okay, right. I just realized that this is the last equation and method that we need to learn. No. There's one more. The one more is excess reagent, Shan. There is one more to go. One more after this. I volunteer my book as test subject on how many commendations can fit on a page. Okay, Ashley. All right, I'll take that. Take it. Definitely. Ceiling fan. Can you guys just see my ceiling fan? Oh no, have I not done it properly again? No, it's okay. It's all good. It's all good. Right, okay, hide that bad boy. Okay, so water crystallization. I am so sorry, year 10. The very first question, and you know what? The last thing I ever want to do is to give you guys a question which would make you question the way I'm teaching it. And this question is direct. This is A-level. So don't get me wrong, I love the fact that I have given you one, and it'll be amazing to see how many of you guys get it. But this is A-level, this is not GCSE. It was much harder. So let's run it. It was a great question, by the way. Let's go through it. So it says, I have a sample of hydrated salt, which is CuX2.6H2Os. And it says that we have a 0.97 gram sample, and it is heated to give me, and so I'm going to end up with CuX2, all the water disappears, yeah, the water evaporates, yeah, and we get 0.538 grams of the leftover anhydrous. I like it. So the question is, who is X? And this is genuinely A-level. It's really challenging. So the first thing that we're going to do is we're going to run our process, because even though students often get really find the transition from GCSE to A-level quite challenging, and I seem to find that me doing these webinars and giving these homeworks out, it definitely seems to be making it slightly easier for you guys to understand things. And I've done something well this year, which is nice. So if we run the process as normal, I think what we would agree is the one thing we know the mass of this guy. Yeah, the anhydrous is without the water. So we know we've got 0.538 grams of that. Well, the first thing we can do, and this is the GCSE bit, and the first mark that at A-level is the GCSE step. So we're going to first of all work out the amount of water, 0.97 minus 0.538. And I'm going to do that on my calculator. 0.97 not divided by 0.538. And I get a mass of 0.432 grams. There we go. Okay, so now that we've got that, what we can now do is turn it into moles. Now, this is the normal process. However, we know we're going to use grams over rams, but the problem is we don't have the rams for this guy because we don't know who X is. What we can work out is the moles of water. So if we do 18 for GCSE, it was A-level, it'll be 18.0. But now we can work out the moles of water, which is 0.432 divided by 18. And that's going to give me 0.024 moles. Now, here's the massive leap of faith. The equation told us that we had 6 waters. So if I just quickly write that down here, CuX2.6H2Os. Here's the massive leap of faith. There's a ratio inside the molecule, and the ratio is 6 waters to every 1 copper X2. So what we can do is, now that we've got to moles, we can use this ratio inside the formula. Oh my Lord, that is a massive step up from GCSE. To be able to recognize a ratio within a compound, guys, this is hard. So what I can now do is if that's divided by 6, then I can divide this by 6, and I can get the moles of copper X2. 0.024 divided by 6. And I get shift N on my calculator, 0.004 moles of, so that now, I now have CuX2, and I have 0.004 moles of it, but I also know from the beginning of the equation, I also have 0.538 grams of it. Guess what equation ties mass and grams together? Number of moles is grams over rams. What do I have? I have grams and I have moles. I can reorganize for rams. Bring rams over. Number of moles times by rams gives me grams. Bring moles down. Number rams equals grams over moles. Right, there's my equation. Massive step up this, folks. Enormous. So the rams is equal to 0.538 divided by 0.004. And I get 0.538 divided by answer gives me 134.5 is who I end up with. Right. So guys, here's now the next. This is a massive, massive A-level question. That there is the relative formula mass, because it's ionic, the relative formula mass of that. I can now minus the copper, which is 63.5. So I minus 63.5 of that, and I get 71. X2 must equal 71. Divide both numbers by 2, and I will get X. X equals 35.5, which is chlorine. How that is hard, folks. Like, you have no idea the level of that question. That there is grade AB at A level. If you're able to have done that, I am absolutely chuffed to bits. Can I have a quick shout out on the classroom of who managed it? That was hard, folks. Really hard. Quick shout out on the classroom. I got it correct. Well done, Con. Rose, same here. I got it. Yes, with great difficulty. Isabel, if you're doing that, you're in year 10 and you're doing higher level year 12 calculations. Yeah, that's great. But I had a bit of help. That's okay, Shan. Tong's the same. Con taught me. Love it when. Well done, Woa. Ben's like, wow, that was like, that's that, guys. This here is, that was the worst. This here is proper chemistry. That there is amazing. For me to have anybody in year 10, I didn't mean to do it, and I'm so sorry. I am writing you a set of questions, guys, myself, because it's really easy to steal questions and it just be a bit rubbish, and could maybe do it now. Ruby, don't worry. That really was, that was a mistake. I didn't mean it. Yeah, that was really tough. Let's do the next one. Now, this one I'm going to try and fit into the gap. Right. This is normal GCSE. Can I just point out, at GCSE, this here is level 8-9. Yeah. If you're understanding this process, then you're doing a great job. Not 9, maybe an 8. Yeah. So we've got CU. No. What am I doing? CU. I'm going to shrink my pen small as I can. K2CR2O7 line H2O. Right, so a hydrated sample of the whole thing is 46.1 grams. That after it was heated, it gave the anhydrous was 35. So that goes straight in there. So the water's going to be that minus that. Yeah, so 46.1 minus 35.3 gives me 10.8 grams of water. Now we need to count them, turn them into moles. That one's over 18. Everyone knows the MR of water by now. Everyone's starting to get the gist of this. So now we need to divide it by this horrible thing. Do you now see why you must teach calculations in a really good, solid order? Because you can't do this step at any of these questions without being able to do relative molecular mass. Potassium is 39. So the formula of that is potassium is 39 times by 2, plus chromium, which I think is 52. Someone please check me. Someone please check that I'm correct on that, please. Yeah. And then oxygen, which is 16 times 7. Let's run that through my calculator. 39 plus 39 plus 52 plus 52 plus bracket 16 times 7 gives me 294. Am I right? Yes, thanks, Rue. Appreciate it. Right, now I get my moles. 35.3 divided by 294 gives me 0.120. These are the moles. Yeah, and then 10.8 divided by 18, which gives me 0.6 moles. Divide them all by the smallest, 0.120, 0.120, and I get 1. 0.6 divided by 0.120 gives me exactly 5. X equals 5. I'm done. Winner. That there is GCSE. GCSE. That's the GCSE song, by the way. No one remember that. And then I realized that I'd given you these questions, and half of them aren't find X. I'm an idiot. Yeah, I'm sorry, guys. It's a really bizarre mixture of stuff. So far, it's out of 2. Question 1, question 2. Next, what is the percentage of water found in barium chloride .2 H2Os? Right. This is not a find X. This is not water crystallized. This is percentage composition. Yeah, I have taught it to you. You can do it. This is just a percentage composition question. So we want the wanted MR over the total MR times 100. Right, we want the water, but there's 2 of them in it. So we've got 18 times by 2. 18 times by 2. 2 times 18 is 36. 36 over, right, the whole thing. So the whole thing is going to be BA. I have no idea what BA is. What's barium? It's massive. 137. It's enormous. So we've got 36 over, I've forgotten what that was now. 137. 137 plus 35.5 times 2 plus brackets 36. Yeah, let's add those all together. 137 plus 71 plus 36 gives me 244 times 100, and that's going to 36 divided by 244, and I get an answer times 100 gives me 14.8%. Ticket if you've got it, folks. As I said, oh wait, wrong question. Could you do like, have I gone the wrong question? What question have I done? Have I done something wrong? Oh wait, one question, never mind. Okay, I'll ignore it. Okay, find the percentage of anhydrous salt in the hydrated. So this is another percentage. I'm sorry, folks. This is what happens when you steal questions from the internet. You get garbage. So I've just got to make it myself. So I'm busy doing them. Yeah, percentage composition again. So this again is wanted MR over total MR times 100. I'm shortcutting, shouldn't really do that. Wanted MR is the salt bit over the total. So what does the salt weigh? So strontium, haven't got a clue. Strontium is 88, folks. There it is. So I've got 88 plus 2 times nitrogen, 2 times nitrogen at 14, and then 6, oxygen 16 times 6. Add all that together. 88 plus 28 plus brackets 16 times 6. Go. 212. Yeah, that's going to be all worth 1 mark, that is. So I want 212 over. What's the total? Right, so now what I need to do is I need to do the total is 212 plus 4 waters, brackets 4 times 18. Yeah, so 212 plus brackets 4 times 18 gives me 200. Total is 284. So total is 284 times 100, and I get my percentage 212 divided by answer times 100, and I get 74.6%. Ticket if you have it, folks. Winner. Will we get marks if we're not to 3 significant figures? Isabel, That's a really great question. In your exam, they will probably tell you what significant figures to give it to. The rule is always 3. If you haven't today, I'm not bothered. Today, I am not testing you on significant figures. Yeah, so you can have it. If you've done good chemistry, you can have it. Right. Oh, this still isn't a find X, but you could easily make it. ... find X. I'm going to do that anyway, just for fun and games. Right. Sodium carbonate sample of hydrated was heated. So I've got sodium carbonate, H2O, right, was 5 grams of the hydrated. So this is .x H2O, heated to give me 1.so of the anhydrate. So that's 1.85 grams there. The question is, what's the water? 5 minus 1.85 gives me 5 minus 1.85, and I get 3.15 grams. Right, turn them into moles. Right, I don't know what sodium carbonate is. Sodium is 23 plus 23 plus 12 plus 16 plus 16 plus 16. 106. Yeah? So now turn them into moles. 1.85 divided by ants divided by 106 gives me 0.0175. And then 3.15 divided by 18 gives me 0.175. That tells me I'm absolutely correct. 0.0175. That gives us a 1. And then that one, 0.0175, gives me 10. So the value, the percent, now it actually wants me for the percentage. So the actual formula is Na2CO3.10 H2Os. And it says what percentage of water is in the hydrate. Well, we could have done this. I've done this the long way. Done it the long way. Because what I could have done is just done, oh, I'm going to show you it. I'll show you both. Yeah, we could have done what was the percentage of water in the hydrate. Well, we worked out the grams and the total thing weighed 5. So we could have done percentage comp of water, percentage comp of H2O. We could have done water was 3.15 over the total of 5 times 100, and that's going to give us the same percentage. 3.15 over 5 times 100, and I get the answer is 63%. Yeah, alternatively, I could have then gone total for water. So 10 waters is 18 times 10, so that's 180. Yeah, so wanted MR, so 10 waters, wanted MR over total. Yeah, so that's 10 waters at 18, so that's going to be 180. Yeah, 180 over the whole thing, and that's going to be 180 plus, that's 180 here, plus sodium at 23. Yes, plus 23 plus 23 because there's 2 sodiums. Yeah, plus 12 for the carbon, plus 16 plus 16, 16 plus 16. Gives me a total MR of 286 times 100. It's going to give me exactly the same figure. 180 divided by 286 times 100 times 100 gives me 63%. Winner. It actually says 62.9. See, that's actually more accurate than doing it the other way. Yeah, this is the question I was asking. Ah, okay. So 2 methods to get there, folks. But I would have loved to see you guys having done that as well. But the answer was 63. If you got it, you get your mark. Next, how much anhydrous will remain? Kind of sounds like Christmas. Oh, what does? What? Getting given stuff and then it's different. A 2.5 gram of a hydrate sample was heated to constant mass. How much anhydrous remains? Oh, what a clever question. Right. So hang on a minute. Oh, isn't that clever? We can do this via percentage composition. Yeah, so I have 9 H2Os over Na2S.9H2O times 100 will give me its percentage composition of water. Yeah, I should go the other way around. They want the anhydrous salt left. Yeah, otherwise I'm going to have to flip it. Let's change that over. Yeah, let's do that. What that will give me is the percentage of sodium sulfide. Guys, it was deck the halls. You singing. Sodium sulfide. Yeah. Right, let's fill in some numbers. Sodium is 23 times by 2 plus sulfur, which is 32 times 1, all over Na23 times 2 plus sulfur 32 times 1 plus brackets 9 times 18, the MR of water. We love water. Let's do the top one first, 23 plus 23 plus 32. So that gives me 78 over 78 plus 9 brackets 9 times 18. That makes things easier. 240. Yeah, times 100. It's going to give me the percentage. So 78 over 240 times 100 gives me 32.5%. Yeah, and then multiply that percentage by 2.5. That was hard. 2.5 grams multiplied by 0.325. If you want to divide it by 100 and times by 32.5, you can do. Yeah, if you want to do that, yeah, divide it by 100 if you prefer. Some people prefer this. They understand it better. I don't mind whichever one you do. Yeah, 0.025 and then multiply that by 32.5. Some people seem to prefer that in their heads. I think I'm actually one of them. So I'm going to end up with 0.813 grams left over. And that's it, folks. Boom. I promise I will actually give you a worksheet on your classroom, folks, where it actually gives you water crystallization questions, because none of these were water crystallization questions. Amazing if you could get it. So, guys, you can fill in your data for me. I think I've actually got my... there we go. Year 10 homework data sheet. If you could fill in your... It's out of 7. Is that out of 7 or 6? Oh, hang on. What's it out of? 1, 2, 3, 4, 5, 6. It's out of 6. Winner. So if you want to fill your data in, that would be grand. Yeah, you can fill in your data and I can see how you guys all got on. Wow, I'm doing really well on the time today. Sean Lee, 6 out of 6. Outstanding. Tong smashed it. You guys are doing so well. Like, I'm seriously impressed. You guys are doing fab. Ashley, superb. Well done. Right, guys, I'm going to crack on with my lesson. Today's lesson is percentage yield. What's my time? Can someone just quickly make a note of my YouTube stream time so I can do start of percentage yield? Yeah, that's probably worthwhile noting. I don't exactly know how to do that now. StreamYard. I'm at minute some. It doesn't actually tell. Oh, no, it doesn't actually tell me. 27 minutes. Yeah, thank you. Someone changed the font. Yeah, I know someone did. I noticed that. Funny. Title is percentage yield. Percentage yield. Cool. So this is a really, really easy. Oh, thanks, Ro. That is great. Thanks for that. Percentage yield, learning objectives. Yeah, no knowledge, no equation for percentage yield. It's the easiest thing ever, folks. This is one that I can teach this in 5 minutes. Yeah, this is easy. That person's definitely TIFF. Yeah, probably. Equation for percentage yield. Yeah. Then we need to understand practical problems. Yeah, understand practical problems to be able to, and therefore able to explain less than 100% yield. I like it. So we'll understand practical problems and then look at some questions, and I like it. Okay, so equation for percentage yield. So the first thing I think I need to do is I need to do a nota bene here, folks. Nota bene. Not nata. Nota bene. I think that's how you spell it. Or is it nota? I think it might be nota. It is Latin. It's going to be nota bene. That means important notice. And this says percentage yield. Percentage yield is all about practicals. We know in chemistry, we know that we love to make stuff. That doesn't mean much. We love making stuff. Yeah. We love making stuff. That's what chemists do. Ben, was it you who just subscribed? It's amazing. 199, come on. You officially have 200. Yes! Winner! How long is it going to take me before I hit the 1,000 day? I'm thinking never. So we love making stuff, and we have spent, and so question, let's make something. Let's make salt. I want to make household salt. Household salt. I want to make sodium chloride. I want to put it on my fish and chips. Yeah, I want some salt and vinegar for my chips. So I'm going to make some salt. So chemistry, that arrow there. Yeah, we know in chemistry that arrow means creates. Yeah, plateau. Yeah, definitely going to plateau. Yeah, and I want to make sodium chloride. Year 10, what do I need to do to go to the chemistry shop and buy? What do I need to go and buy to make salt? So if you go to Clazada.com, Clazada is the chemistry version of Lazada. Clazada.com. Yeah, it's like the chemistry version. Yeah, spot on, Rue. That's what we're going to buy. We're going to go and buy some sodium, solid, a little block of metal. Sodium metal. There we go. Let's make it shiny and silver. Shiny. Now I'm going to go and buy some chlorine gas. Nasty, nasty green chlorine gas. Yeah. I'm going to go and buy some chlorine gas from Clazada. Toxic, horrible chlorine gas. Nasty stuff. Yeah. And I'm going to put them together in a container and poof, I'm going to make salt. Yay. Okay, so how much salt do I want to make? I want to make 100 grams of salt. I love salt. Is it because it's Clazada? Aha! Oh, Clazada. Yeah, it doesn't really flow so well when it's Clazada. But yeah, sure. They don't just sell chlorine though, Sham. That would be like a pointless website. What do you sell? Chlorine. Who needs chlorine? I don't know. Swimming pool people? Chemists who are making salt? I don't know. Right, guys, here's your first exercise. You can... Oh, tablet's gone mad again. Oh, no. There we go. So, here's your first question, folks. How much sodium and how much chlorine do I need to go and buy? Off you go. Pause the video. And then I want you to... Oh, I need to balance the equation. First thing, oh, I forgot. There we go. Wonder who gets to forget that. Chemazon. Oh my God, that's gold. That's amazing. Yes, I love that, Rue. Chemazon, definitely. Chemazon, that's brilliant. Right, step number 1. Step 1, get to moles. We know this. Whoa, my laptop's doing weird things again, folks. Oh no. Step 1, moles. Grams over grams. What does sodium chloride weigh? Sodium is 23 plus chlorine, which is 35.5. I will lose the mark if I don't actually give the real number. So that then becomes 58.5. Number of moles. 100 divided by 58.5. And I get 1.71 moles. Right, what's the ratio? You can make yourself a medal during class tomorrow. It will be damn cool. Ratio, step 2 is the ratio. And that is a 2 to 1 to 2. Right, so that's easy. So I need to move all those. Should have moved them. So I'm going to get 1.71 moles of sodium, and I'm going to get half that, divide by 2. Gives me 0.85 moles of that. It's actually 85.5. It's actually 5 moles of that guy. Step 3. So step 1 was moles. Step 2 was ratio. We know these steps now, folks. Step 3 is get out of moles. Out of moles. So I need grams. Yeah. So now I do number of moles equals grams over rams, and I'm going to reorganize that. So number of moles times rams gives me grams. See, I've done that on my tablet. No, Mr. Duncan, you should make a T-shirt saying Chemazon with your own logo. Ours Smith. What? Your own logo. Is that anyway. Right. I need to multiply it. How much does sodium weigh? 23. We're getting used to this. Sodium weighs 23. Chlorine is in a pair. So we're going to multiply it by 71 because it's Cl 35.5 times 2 because it's in a pair. So multiply by 71. So that number times by 71 gives me, I need 60.7 grams of chlorine, and the sodium 23 times 1.71, and I need 39.3. Get rid of that. 39.3 grams of sodium. And look what it all adds up to. I love chemistry. That adds up to 100. Gotta love it. Or something. Oh, yeah, okay, I'm with you. So, we're going to go to the shop. Whoop, whoop. So, Mr. Duncan goes to the shop. I'm going to make my pen fatter. Question 2, part 2. Question 1, part 2. Mr. Duncan, Mr. D, buys 39.3 grams of sodium and 60.7 grams of chlorine. How much salt will he make? How much salt am I going to make, folks? Do you know what? This is going to be really interesting. Put on the chat what you think I'm going to make. This will be really interesting. This is going to tell me if you guys watch the other. I think I've done this already with 10A. Be interesting to see how many of you are watching it. What am I going to make? This is going to be interesting, this. Ben, good answer. Well done. It's wrong, but so that is the answer. I'd be happy for you to say 100. I don't know what that means, but like less. I have no idea. Are you speaking in German? Rue, are you feeling all right? Rue Ming says 100, but less. And that's correct, Rue. Yeah, less than 100. You're absolutely right. Guys, the only thing I am not going to get is 100. The answer is not 100 grams. I will make less. Okay, so figured I'd go back to here. I never do this. I don't know quite why I'm doing it on this why this lesson particularly warrants it, but I feel like it does. So, year 10, do any of you guys bake? Do any of you guys bake at home? I bet loads of girls and boys in the room, I bet everyone's baked at some point in their life. Yeah, you've made a cake or muffins or, I don't know, curry puffs. I don't know, kinda. Yeah, exactly. Everyone's baked something. And I love that. Con bakes a lot. I did not know that. I bake even more. That's amazing. So yeah, exactly. Cookies. Yeah, everyone's done cookies at some point. So you get a recipe. You get a recipe and you get all the instructions with how much you meant to use, they burnt. Love it. Everyone bakes during quarantine. Exactly, Ashley. Yes, they do. Totally agree. But you have all these quantities, and I think everyone in this room would realize that when you put everything, all your ingredients, that's ice. Whoa, Mr. Duncan's got that ice. Got that ice? Ice? Anyway, oh, you're talking about this. Oh, just suddenly realized what you're talking about. Everyone agrees that you put all the ingredients, and I know how is exactly your chain. Yeah. You put everything in the container, in the bowl, and you start mixing it. And what you guys all realize is you always lose stuff. You lose it on the spoon, you lose it on the bowl, you lose it in your mouth, you lose it on the floor. Yeah, the problem is chemistry is cooking. And every time you make something, there are losses. You lose stuff because it sticks to the bowl and then you can't get it off and then it's on your fingers and then you have to go and wash your hands. So when the instructions say, add in this quantity, what you need to realize is you're always going to lose some. Now, a lot of the times we don't mind because everyone likes to lick the spoon, right? Everyone does. It's fine. But of course, in chemistry, we're trying to make as much as possible. So we were trying to make salt. Let's go back to our notes. Oh, I miss seeing you guys. It's not the same doing it this way. Let's go back to our notes. So what we all agree is that the one thing I'm not going to get is 100 grams. I will make less. So let's say I will make less. I make 87 grams of salt instead. Let's say that. Well, the question now is, what is Mr. D's percentage yield? And I bet every single one of you know the answer already. Without me even having to teach you this, when I show students that, the first thing they go is, oh, this is easy. I can see the number. Yeah, so guys, give me the answer. What's my percentage yield from that experiment? Let's see who gets it. I'm going to be fascinated. This is why I said I know there's a delay on the chat, which does make things difficult. I lose a couple of minutes because of that. But what's my percentage yield? I want to see who gets on the card. Come on, year 10. What's my percentage yield? Is the right answer. Thank you, Ashley. The answer is 87%. Well done, Nick. Good job. The answer is 87%. The reason why it's 87% is because, and this is now, guys, here's the equation. Percentage yield. My writing is getting bigger and bigger. Percentage yield equals actual output, actual out, brackets, prac out, yeah, actual output over theoretical output. So times 100. So my answer there was my actual output was 87 grams. That was what I actually made. That was my prac out. Yeah. But what did I expect? I bought all the reagents to make 100 grams. This was my output in theory. Theoretic theory out. I times it by 100 and I get 87%. Now that's not bad. I made 87% of what I expected. I would say that was a reasonable practical. Yeah? Let's try another one. Question 2. Let's say I'm Ben, do you know what? Let's do a full, yeah, no, let's keep it easy. Ben calculates, nice one. Calculates, he will make 12.8 grams of X. He actually makes 12.1 grams of X. What's his percentage yield? Off you go, folks. First person. Off you go. Imagine buying ingredients to make 100 cookies, but you only have enough to make 87. Shan, that is exactly right. That is literally right. You buy all the ingredients and you won't make 100 cookies. You will make 87 because you eat, come on. You lick the spoon, it gets stuck to your fingers, you got to wash your hands. Yeah, it's a nightmare. Let's run it. So what did he actually get? Actual 12.1 over theoretical, over theory, 12.8 times 100 gives me on 12.1 over 12.8 times 100, and I get 94.5%. Ben, well done. You did a great job of that. Yeah. It gets stuck to the bowl. Of course it does. Absolutely. Yeah. X got stuck to the bowl. It's amazing. So Ben did a great job. Good job, Ben. Good prac. Not bad. Not bad at all. Right, let's do another one. Right, let's do question 3. Let's do Ashley. Ashley, Ashley, have I spelled your name wrong? I have, haven't you? Oh no, I'm sorry. Ashley, there we go. Lol. Ashley reacts 12 grams of magnesium, 12 grams of magnesium with excess. Now that word might be new to you guys. Ouch. Oh, I'm sorry, Ashley. Please forgive me. Please. I'm sorry. I won't do it again. I'm sorry. The word excess, guys, you need to start recognizing. I have taught it to you already with combustion. Yeah, excess means more than enough. More than enough. Yeah, there's going to be stuff left over. Yeah, so we ignore, whenever we see excess, we just ignore it. So we're going to take 12, Ashley's going to react 12 grams of magnesium with excess oxygen. Right, question number 1 is part A. Write the equation for Ashley's. Part A is equation. Off you go, folks. Impress me. What is the equation of Ashley's reaction? Yeah, I know it's going to be, top 10 betrayals. You guys are mean to me. I didn't mean to. Mg plus O2 because oxygen. And then I'm going to form MgO, balance it, and I'm done. Right. Step 2, B. Calculate mass of MgO. Calculate mass of MgO to be made. So next. So this is a reacting mass now. So we've got step 1, yeah, get to moles. Step 1 is moles. Number of moles is grams over rams. Magnesium is Mg24. So grams over rams gives me 12 over 24 gives me 0.5, 0.5 moles of magnesium of Mg. The step 2, ratio. I'm very aware I've only got 5 minutes left. Step 2, ratio. The ratio is a 2 to 2. That's nice. Ratio is 2 to 2. Yeah. So that means I have 0.5 moles of MgO. Right. Step 3, get out of moles. Out of moles. So number of moles times rams gives me grams. Right, how much does magnesium oxide weigh? Number of moles times by MgO, which is 24 plus 16, which is 40, I believe. Yeah, so times by 40 gives me 20 grams. We're expecting to see 0.5 times 40. So Ashley is going to make, in theory, 20 grams. In theory. Yeah? The last part of the question is, Ashley, part C, Ashley actually makes 18 grams. Percentage yield. You're done. It's the end of today's lesson. We're all finished. Nice and easy. 90%. Great job. So the question is, why did she not get 100? So why did she not get 100? Reasons for less than 100%. Number one, top answer. Our survey said incomplete reaction. Incomplete reactions. She stopped it too soon. Yep, because she ate some of the chemicals on the way. Yeah, don't write that down in your exam. And Ashley, don't do that. It's a bad idea. Incomplete reaction. I love it though. Oh, that's the problem with using the food analogy in chemistry. Incomplete reaction. Answer number two. Impurities in reactants. Well, we bought magnesium, but maybe it wasn't pure magnesium. Yeah? Chemistry family feud. Impurities in reactants. Number three, side reactions. Side reactions. Maybe she's made something else and she didn't see it. Made something else. Yeah. Do you notice none of these are, she hasn't weighed it properly. They're human errors. I hate that. It's not a real answer. Number four, but I've underlined it. This is special. Reaction is reversible. Reaction is reversible. But you can only say that one when you see this sign. Yeah. So for example, ammonia. Yeah, if you make ammonia, then it's reversible. You will not get, there you go. You will never get 100% yield. You can't, because some of it's going to start going backwards. Yeah, and that's the end of my lesson, folks. We did it. Let's check our learning objectives. Equation for percentage yield. Practical problems. Explaining less than 100. Love it. Great job. Today's all finished. Right, guys, look at that. 1 minute to go. You guys need to get to your last lessons. Guys, it's been amazing to see you. I'll post your homework on the classroom for tomorrow. I will do that right now. And I will see you guys tomorrow. Have a good rest of your day, guys. See you soon.